Hello everyone, welcome to AS Engineering Academy and AS Online. This is Ramesh Pabba, faculty at AS Engineering Academy. In this today's session, we are going to discuss about RRB JE, right, Electrical Engineering revision series with PYQs. We are going to take previous year questions. Along with those question solving, I am going to give the corresponding theory and explanation. The subject name called measurements. So from the measurement subject, electrical, electronic as well as transducer part, related PYQs will be taken. Along with the PYQs, explanation, relevant corresponding topic also will be given. Let us start the topic now. The first question is here. Errors which may be variable both in magnitude and in nature. He is saying that errors are variable both in magnitude and nature, that is either positive or negative, are classified as a dash error. So what is the meaning of this? So errors are changing in magnitude wise as well as nature wise. Everything is changing means the errors are randomly changing. So therefore the error is nothing but random error. Now in other way, hysteresis error, with one notation it is changing. Interaction error, no way. Systematic errors are how many? Instrumental error, environmental error and random environmental error as well as correspondingly observational error. Therefore these errors are related to the random. So therefore this is coming as answer. Right. Second one is, the use of dash instruments is merely confined within laboratories as standardizing instruments. Kindly see the complete question. They are asking like, used within the laboratories. These are not our college laboratories, etc. These are laboratories as which one? Standardized instruments. So these are the instruments used as a standardizing purposes in the laboratories. So which we use generally? We are having absolute instruments as well as secondary instruments. Two instruments are there. Absolute instruments are also called as primary instruments. Secondary instruments are classified into three types. One is indicating instruments, second one is recording instruments, and third one is integrating instruments. So all these instruments are used for the measurement of corresponding current and voltage, etc. Some other parameters will be used. But in order to have standardization of all, or in order to design all these instruments, one reference must be there, that is called a standard we require. That's why these instruments are used for the purpose of standardizing in the research laboratories. We say he has given that simply in the laboratories. Therefore answer here is absolute instruments. Sir, indicating, recording, integrating are coming under secondary. These are the common usage instruments. So automatically option will be the absolute instruments. Right. Next question. Which of the following instruments indicate the instantaneous value? Kindly focus. Which of the following instruments indicate the instantaneous value of the electrical quantity being measured at the time which it is being measured? So what does it mean? The moment we give the supply, at the time, at that particular instant of time, the value should be shown. For example, if the supply is given 2 amperes is flowing, so it has to show 2. Suppose at that time 3 amperes is flowing, it has to show 3. Therefore this is called as at that particular instant of time. Nothing but indirectly these are the instruments which are indicating the value at the given instant, of time. So therefore answer is indicating instruments. Absolute instruments are for which purpose? Standardization purpose, etc., reference purpose. Recording instruments will be giving the overall value in the graphical representation in a given time, and integrating instruments will be giving the corresponding value as the total cumulative summation. So therefore answer will be indicating instruments. Right. Next question. Which instrument is not categorized as secondary instruments? Earlier model only, but the question is changed. Now try to answer, guys. I will be checking your answers. Try to answer kindly, those are online. Those are online, kindly respond. I'm checking your answers. Kindly respond. Right. So answer here is which are not categorized as instrument means absolute instruments. Right. Okay. Now next one is which of the following errors occur in a moving iron instrument? In moving iron instrument, which of the following errors are occurred? Right. Okay. Now those who are watching kindly respond. Here in the moving iron instrument, which errors will be there? Temperature errors are present, and what is that? Hysteresis errors are present, and stray magnetic field errors are also present. Why, sir? And the two frequency errors are also present. Sir, MI instrument is applicable for both DC and AC. Therefore, AC means frequency errors are present. And iron content is there, so automatically magnetization, hysteresis. And then based on the current operation, temperature, yes, it will be there. And the two, moving an instrument is having electromagnet, so definitely that will be affected by external magnetic field. Therefore, stray magnetic field errors, all these errors are present. Check it, stray magnetic field error correct, hysteresis, temperature, therefore answer will be all of the above. Therefore, answer will be all of the above. Yes, people are giving the answer, very good. Right. Next one. The measurement errors mainly caused by human mistakes. In the class also I told you, the human being mistakes are categorized into one error called gross error. So, direct answer, yes, gross error. The human being mistakes are categorized into gross error. Other errors are systematic error. In the systematic error, instrumental error, observational error and environmental error will be there. But only due or mainly due to human being mistakes means gross error in observation, in recording, in calculation. So, everywhere with respect to human being mistakes. Right. Next one, yes, very good, gross error. Yes. Next one is a galvanometer is converted into a voltmeter. Nothing but what is the meaning of this question? A small range meter is converted into a voltmeter. Nothing but indirectly voltmeter extension is happening. How can we make it? Galvanometer means generally small capacity we say. We are going for conversion into voltmeter. By which one? Guys, voltmeter extension is happened by, voltmeter extension will be happened by which one? High resistance in series. Yes, people have given the answer, very good. What is the answer? High resistance in series. Yes, correct, first option. Adding low resistance, wrong. And increasing number of windings, wrong. Decreasing the number of windings, not at all. So, simply by connecting high resistance in series with the galvanometer, that is simply acting as voltmeter. Very good. People are giving the answer. One student gave the answer B, 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 B. Kindly concentrate. Low resistance in parallel. This is for, the second option is for ammeter purpose. But he is asking voltmeter. That's why be careful with the options. Right. Next one. Match the following. Kindly answer. Take 30 seconds of time and try to give the answer. Transformer, rectifier, ammeter, megger. Now, see, if any question is appeared as match the following, follow one technique. Out of all, whichever is easy to observe. So, kindly take that. Megger is insulation resistance. So, therefore, S is with 2. So, S1, S4 over, leave it. S1, S4 over, leave it. In that way, eliminate, try to eliminate the corresponding option. Now, which is correct, tell me? Megger meter, S2, okay, S2 is there. P3 is there happily. What is that? Yes, transformer, step down the voltage or step up. So, step down is matching, no problem. And next one, what are the remaining parameters now? Rectifier and ammeter. Ammeter measures the current directly, R1. So, therefore, R1, S2, this R4, no, got it. So, simply option. In that way, try to go with the known parameters, ammeter current, Megger insulation resistance. So therefore, R1S2, only one option is there, go for this. In that way, save the time. No need to go for all the 4 compulsory. Simply see the options. If 1 or 2 are matching, yes, go for it. No issue. Right? Yes, few people give the answer. Very good. Next one. An ohm meter is, sir, ohm meter, in the class also I told you, ohm meter is basically an ammeter. The two, which one? PMMC, moving coil type of meter. So therefore, yes, it is moving coil instrument. Ohm meter is basically a moving coil instrument because PMMC structure, yes, moving coil instrument. Right? Next question. Which of the following essential features is possessed by an indicating instrument? Now tell me, out of all these 4 options, which is suitable for this one? Which of the following essential features is possessed by indicating instrument? Is or are? We can write is or are, possessed by indicating instruments. Tell me guys, which is the correct option? Right? See, in any indicating instruments, we require deflecting torque, we require controlling torque, and we require damping torque. Deflecting torque, controlling torque, as well as damping torque. Okay, so therefore these are essential. Here, okay, deflecting structure, torque related structure, controlling device, okay, damping device, okay, but see the option, deflecting, controlling and damping structure. Yes, definitely option D. Actually all are required. Anyway, all of the above is given, so simply option D. Yes, very good. Balaji and Abhi both are giving the answers. Very good. Right, next one. The pointer of an indicating instrument should be, no, it is very practical question. Pointer in any moving instrument, suppose PMMC or MI or EMMC, pointer will be there in the instruments. That pointer should be of very light or very heavy structure. Definitely light. Why, sir? To reduce the inertia, to reduce the frictional effect. So simply we can say very light. The pointer of an indicating instrument should be very light, compulsory. Right? Yes, option A. Very good. Next one. An ammeter is a dash instrument. An ammeter is dash instrument. Try to answer. Ammeter is dash instrument. What we can write? See, here absolute instrument. For this, what is the example? Tangent galvanometer. One of the examples is tangent galvanometer. Okay, leave it. Recording instruments. Recording instrument, what we can say? ECG we can say, and then seismograph we can say, etc. Integrating instruments, which one? Energy meter. Integrating instrument is nothing but example energy meter. Now, ammeter is, so which is the optimum possible one? So simply secondary instruments. Actually speaking, in the secondary, indicating, recording, integrating will be there, but integrating energy meter and correspondingly recording instrument ECG or load flow analyzer, etc., and then absolute means tangent galvanometer. So based on the available options, this is the appropriate one. So therefore secondary we can say. Right? Very good, very good. Right, next one. Which of the following materials used in fabrication of swamping resistor? Fabrication of swamping resistor. This is M. Swamping resistor. Tell me, swamping resistors are made up of dash material. After extension of range RSH and RESC, after that we have taken the point. What is it? The extension of range of ammeter or voltmeter is done by shunts and multipliers respectively, and generally those are generally made up of which material? Anyone? Right, very good. Yes, what is the answer? Manganese. Manganese. Why, sir? The manganese has which type of property? Constant temperature coefficient of resistance, right. So therefore, based on this we can say that yes, it will not be affected by the corresponding temperature much. So therefore, out of all this, manganene, whatever the resistor which is made up of constant temperature coefficient of resistance, that is manganene material, is called as swamping resistance. It is called as swamping resistor. Clear? Any other doubt? Swamping resistor, right. So swamping resistors are generally made up of, what is it? Manganene material. Right. Next one. Very good, people are giving the answer. Try to give the answer. The extension of range of ammeter, and voltmeter. Guys, concentrate. Extension of range of ammeter and voltmeter can be made respectively by, extension of ammeter should be done, extension of voltmeter should be done, that is respectively. Now tell me, extension of ammeter will be done by RSH. So therefore, for this what we require? RSH. For this what we require? RSE. RSH is called as shunt, RSH is called as shunt, RSE is called as multiplier. RS is called as multiplier. So therefore, yes, using multiplier and shunt respectively, he has given multiplier for ammeter, voltmeter, shunt. So wrong. So therefore, kindly focus. He is asking correspondingly respective words. So therefore, first shunt should be there, then multiplier. Yes, what is that? Using shunts and multipliers. Using shunts and multipliers. Here, series capacitor, series inductor, reducing the spring tension, all are wrong only. So simply by using shunts and multipliers. Clear? Right. Okay, few people give the answer. Very good. Right. Next one. The meter suitable only DC, suitable for only DC measurement. Tell me, the meter suitable for only DC measurement. So which meter is suitable only for DC measurement? Come on, right? See here, moving iron type instrument. Moving iron type instrument is for DC as well as AC. Electrodynamic type is also, what is it? DC and AC. Hot wire is also suitable. So therefore, only means simply this is only for DC. So therefore, what is the answer? Permanent magnet type, that is PMMC instrument we can say. PMMC instrument is applicable only for DC. That too, we have taken, it always measures which value? Average value. It always measures average value, right? Okay, people give that PMMC, very good. Right, next. The most efficient form of damping, nothing but most effective damping, which is strong damping, which is effective, which is efficient damping out of all. We are having air friction, we are having fluid friction and eddy current damping. Out of those three, which is highly effective? Simply, in the class also I gave the summary point, order of efficiency or effectiveness we can say, order of effectiveness. What is the order? First one will be eddy, later fluid, later air. So therefore, which is the highest efficient? Nothing but eddy current. So therefore, eddy current damping torque method. Clear? Right. Next one. Damping of deflecting type instrument is done to, nothing but why we are providing damping torque. Why we are providing damping torque, right? Take 30 seconds of time and answer. Damping, why we are providing the damping, the meaning of this is why we are providing the damping torque in the corresponding deflecting type of instrument, that is indicating instrument, etc. Tell me. See, make the moving system slow? No. Make the moving system fast? No. Reduce the angle of deflection of the pointer? Not at all. So therefore, actually, what is the Definition of damping torque: it is the torque developed in the instrument to stop oscillations of the pointer at which one? Final position. So simply reduce the oscillation of the pointer in the final deflected position. Yes, this is correct. Clear? So therefore oscillations must be nullified. That is what the point he has given, reduce the oscillation. Right? Next one. Which of the following decides the time response of an indicating instrument? He has given that time response. Which of the following decides the time response of an indicating instruments? Which will decide the time response? Guys, simply suppose I am taking here, this is final position of the pointer, right? It is moving, making some oscillations like this. For example, if it is keep on making oscillations, based on that only corresponding what is the time response will be there or not? Now tell me how fast it is stopping. Nothing but all these oscillations must be nullified by providing what? Damping torque. Therefore if you are providing the damping torque, these oscillations will be nullified. If you are providing the damping torque, these oscillations will be nullified, then automatically the response time will be taken. So that's why based on how the damping torque is acting, how effectively the damping torque is acting, based on that time response will be there. So that's why what is the answer? Damping system. Deflecting system is only to move the pointer from 0. Controlling system is to oppose the pointer movement to reach or to go to the near to the final value. But at final position without making oscillations, it has to be stopped, means definitely what we require? Damping. So therefore answer is damping system. Okay, for this no one, yeah, very good, one student gave the answer. Next one. Which of the following is essential features is possessed by an indicating instrument? Same thing already we have taken. In the indicating instrument, which are the following? All these are previous questions only. Which are the following essential features is possessed by an indicating instrument? Guys, deflecting device we require definitely, controlling device we require, damping device we require, but in this option deflecting, controlling, damping, yes, all are required. So therefore all are given, not individually. So therefore all are given, no, that will be the correct one. Right? Next one. In measuring volts and amperes, it's very simple question, but statement formed in different way. Measurement of voltage, measurement of current, that's what in measurement or in measuring volts and amperes, the connections should be made with. Now tell me, in order to measure the voltage, voltmeter, okay, voltmeter is given. In order to measure the current, ammeter, yes, all options are ammeter given, okay. But sir, the connections should be what? Nothing but voltmeter should be in a parallel, ammeter should be in series. Yes, voltmeter series, wrong. Voltmeter parallel, ammeter series, correct. Voltmeter and ammeter series, wrong. Voltmeter and ammeter parallel, wrong. So therefore what is the answer? Yes, voltmeter should be in parallel for sure for voltage measurement, ammeter should be in series for current measurement, right? Okay, next, answer this. In a portable instrument, the controlling torque is provided by. Portable instrument means simply we can carry this is a portable device. In that, which type of controlling torque we can prefer? Already we know that spring control method. Why sir? It is suitable for both horizontal and vertical mountings. Suitable for horizontal and vertical positions. It is applicable for both. That's why portable. Therefore portable devices, yes, spring control method. Gravity control method is only for which one? Vertical positions. That's why. So which is suitable for our corresponding, what is it? Portability means both. So option Yes, spring control, very good. Next, right, it is conceptual based only. 2 meters X and Y require 40 milliampere and 50 milliampere for full scale deflection. 40 milliampere and 50 milliampere for full scale deflection. Which of the following is correct? Which of the following is correct? See the options first. Sensitive, sensitive, sensitive. So he is talking about sensitivity. So therefore, we need to concentrate on sensitivity topic for this. Now tell me, what is a sensitivity? Sensitivity of X meter, but 1 by IFSD, 1 by 40 milliampere, and sensitivity of Y meter, sensitivity of Y meter, 1 by 50 milliampere. Now tell me, which will be more? 1 by 40 is more than 1 by 50. Therefore, which will be more sensitive? Which will be more sensitive? Right? High sensitivity with respect to this one. So therefore, which one? X is more sensitive. X is more sensitive. We are not saying it is less sensitive, it is comparatively this is more sensitive, this is less sensitive than this one. That is why among those two which is cut here. So therefore, X is more sensitive. How can you find out? Means 1 by IFSD notation. Right? Next one. Power factor meter has. So in power factor meter, one current coil will be there like this. Power factor meter, one current coil, but we are going to have two potential coil circuit like this. We are going to have two potential coil circuits. Therefore, one current coil and then potential coils are simply two. Check it here. One current and one pressure, wrong. Two current circuits, wrong. Two current circuits, wrong. Simply one current circuit, two pressure circuit. Pressure means potential coil circuits. So therefore, answer will be one current circuit and two pressure coil circuits. Right? In the power factor meter, this is a simple idea. Potential coil has two circuits like this. In the current coil has only one. Therefore, one current circuit and two pressure circuits. Right? Next one. Which device is not used for extending the range of instrument? Very, very simple. Now tell me, see the options and tell me which device is not used for extending the range of instrument. Sir, shunt, we can use it for which one? Extension of range of ammeter. Multiplier, extension of range of voltmeter. Current transformer, extension of range of MI ammeter. So all three are there, but simply switchboard. Come on, how can we use a switchboard for extension of range? No way. That's why answer will be switchboard. Very simple question. Right? Next one. It's one numerical question. When a voltmeter ammeter method is applied for the measurement of resistance, so they are using what is that? Voltmeter ammeter method for measurement of what? Resistance. Voltmeter reads 8.28 volt. Voltmeter reads 8.28 volt and ammeter reads 4.14 milliampere. Then the value of resistance. Very simple. Resistance is equal to voltmeter reading. Resistance is equal to voltmeter reading by ammeter reading. Why, sir? He has used voltmeter ammeter method. R equal to V by I. So voltmeter reading by ammeter reading. What is voltmeter reading? 8.28 volt by current value ammeter reading 4.14 milliampere. Sir, it will be 2 times milli commit numerator. So simply 2 kilo ohm. Direct answer is 2 kilo ohm. So therefore, yes, answer is this 2 kilo ohm. Clear? No one has given the answer for this. Right. Next one. In a permanent magnet moving coil instrument, the deflecting torque is directly proportional to which device? permanent magnet moving coil means simply PMMC. In PMMC instrument, the deflecting torque TD is proportional to dash. Very simple. In this, what is the formula, guys? TD is equal to BIN into A. BIN into A. B is a constant, N is a constant, A is also constant. Therefore, we can write TD is proportional to I. TD is proportional to I. So, therefore, current passing through the coil proportional to current passing through the coil. Right? Now, here flux density in the air gap, correct? Flux density in the air gap, correct? Number of turns in the coil, number of turns in the coil, correct? So, therefore, what can be the option now? All options are correct. Right? Suppose if these two are not given, then we can go for yes, current passing through the coil, but all options are given and the two, all of the above is also given. Yes, all are correct only. Nothing but just directly based on the formula. This is correct, TD proportional to B, TD proportional to N, TD proportional to A also. If these are not given, first is the answer, but all are given, all of the above. Yes, very good. This is not required. Right. Next one is, wattmeter cannot be designed on the principle of, very important point, wattmeter cannot be designed on the principle of electrostatic instrument we can, thermocouple we can, electrodynamic we can, but I told you in the class MI instrument base, MI principle base, wattmeter will not be there. That's why moving iron instrument. Generally, which of the following is odd one out? MI wattmeter, not possible. So, therefore, moving iron instrument principle cannot be used for wattmeter connection, cannot be used for wattmeter connection at all. Right? Next question. In an energy meter, braking torque is produced, nothing but why we are producing the braking torque? Braking torque is produced for which purpose? Can you respond? Braking torque is produced for which purpose? Safeguard it against the creep? No. No. Break the instrument? No. Okay. Bring energy meter to standstill? No. What is the meaning actually? Maintain steady speed and equal to the driving torque. That's why the braking torque with permanent magnet we are providing to have the corresponding speed required, steady speed we can say. That's why maintain speed and equal to the driving torque. Clear? Right. Next one. The household energy meter is whatever the energy meter we are using in our home, we can say household energy meter. Which type? Sir, indicating instrument. No, energy meter does not come under indicating category. Recording instrument. No. Both integrating and indicating. No. Indicating means at a particular instant of time. Recording means it has to record all the values just like on the graph paper, etc. But does it do? No. Simply over a period of 1 month. So, how much energy we utilize, how much amount we have to pay, nothing but cumulative summation of energy utilized over a period of 30 days. That is why it is coming under cumulative summation, nothing but integration. Therefore, energy meter is example for integrating type. Okay, very good. Yes, people are giving the answer. Okay. Next. The resistances in the circuit of the moving coil of a dynamometer wattmeter should be. Now tell me, in the resistance in the dynamometer, that which one? Moving coil. Now tell me, take 30 seconds of time and tell me which is the correct answer. Moving coil resistance is a dash in dynamometer wattmeter. Moving coil resistance is dash in dynamometer wattmeter. Anyone tell me? Right. See, first of all, you are supposed to understand the question first. What is it? Moving coil. Which is the moving coil? potential coil is the moving coil. Potential coil is the moving coil. In the wattmeter, current coil is a fixed coil, potential coil is the moving coil. So therefore, the potential coil should have very high resistance. So therefore, simply almost zero, low, very low, wrong. So simply high. Nothing but indirectly he is asking potential coil resistance is dash, but to confuse you, potential word is not given, only moving coil word is given. Moving coil is nothing but our potential coil only, right? Okay, very good, high. Next one, in a low power factor wattmeter, the compensating coil is connected. Which meter? LPF wattmeter, low power factor. Therefore, LPF wattmeter. In LPF wattmeter, the compensating coil is connected. The compensating coil is connected in dash. Very important point. The compensating winding is connected in series with the potential coil. Remember, in this way, current coil will be taken, and here this is the potential coil, this is the supply circuit, and this is the load. Okay. Now this is CC and this is PC. Now where we connect the potential coil, where we connect the corresponding compensating winding, the compensating winding will be taken here, not connected to current coil. This is compensating winding. It is not connected to current coil, connected in series with the potential coil, series with the pressure coil. Here series with the current coil, wrong. Parallel with the current coil, wrong. Series with the pressure coil, yes. Series with the potential coil. In a parallel is wrong. How check it? This coil is connected in series with the potential coil to compensate the losses in the potential coil. Therefore, connection is series with pressure coil. Pressure coil or potential coil, no issue. Right? Next one. In three-phase power measurement by 2 wattmeter method, the reading of one of the wattmeters is 0. Reading of one of the wattmeter is 0. So simply then power factor. What is the power factor formula? Cos phi is equal to cos of tan inverse root 3 W1 minus W2 by W1 plus W2. Right. So one of the wattmeters reading is 0. Kindly focus. Assume that W2 is 0. Assume that W2 is 0. Then W1 cancelled. Tan inverse root 3 60. Cos 60 half. So therefore, what is the answer now? Yes, simply 0.5. Yes, 0.5 is the answer. Right. One of the wattmeter reading is 0 means 0.5, because it is 0, for example. Next one. Induction wattmeter can be used in induction type of wattmeter. Induction type of wattmeter can be used in, sir, induction process, definitely only AC. Induction process, definitely only AC. So AC circuits only. Right? Next one. In a three-phase power measurement using 2 wattmeter method, if 1 wattmeter is negative, it means, I give 5 points in this. So therefore, 1 wattmeter is negative, nothing but he has not given any relation, equal or not equal. Simply W2, for example, W2 is negative. When will happen? Nothing but power factor is neither 0 nor 0.5. Power factor is neither 0 nor 0.5. When one of the wattmeters reading is negative, then power factor range will be 0 to 0.5, neither 0 nor between these two. So simply, yes, what is that? Power factor is unity. Power factor is greater than 0.5, no. Power factor is less than 0.5. Power factor is less than 0.5 lagging. Now the question is, among these two, anyway, lagging and leading are not given. Simply power factor is less than 0.5 we can take, power factor is less than 0.5 lagging, no need to worry. Anything you can take it, generally 0.5 you can take it, no problem. Nothing but less than 0.5. Okay, right. Next one. Measure is an instrument to measure. Measure is an instrument to measure. What is that? Quality factor of the coil, inductance of the coil, very low resistance, insulation resistance. Tell me, measure is an instrument. Measure is an instrument for which purpose? Measure nothing but high resistance, the two insulation resistance. High resistance nothing but insulation resistance. Right? Next one. For measuring very high resistance, we should use measuring very high resistance. Question is reversed. Kelvin double bridge method is for low resistance. Wheatstone bridge method is for medium resistance. Measure is for high resistance. Sharing bridge is for capacitance. So all options I explained. Now tell me which is one. High resistance, the two high or very high, no issue. Measure is the answer. Yes, insulation resistance and measure, correct. Next, in a measure, controlling torque is provided by, very important note, in the measure the controlling torque is provided by the coils itself. There is no spring, etc. Very important point. In the measure, we don't have any spring action. Like power factor meter also, the spring action will not be there, but the controlling torque is provided by which one? Coils itself. Therefore, by the coils only we are going to get the opposing force, etc. Right? No, spring we don't provide. We provide the controlling torque in with respect to coil notation in measure as well as power factor meter. Measure as well as power factor meter. In both the cases, we are using coil, nothing but with the coils only. With the coils only, we are going to get the controlling torque. Other than these two, everywhere, yes, your answer is correct. Spring, right? Next one. Low resistance value can be measured accurately by using low resistance. Simply measure high resistance, ohm meter medium resistance, multimeter all categories will be there. So therefore, Kelvin double bridge. Here check it in the earlier question, Kelvin double bridge low, and he is asking low resistance is by dash, Kelvin double bridge method. Right? Next question. Which of the following devices should be used for accurate measurement of low DC voltage? That too he mentioned accurate measurement. Guys, moving coil okay, working properly, but in the options DC potentiometer is there, we have to go for DC potentiometer. In the concept explanation also I told you DC potentiometers are even more accurate even compared to which one? DC potentiometers are more accurate even compared with respect to moving coil voltmeter. That's why simply DC potentiometer is the answer. If this is not given, obviously small range PMMC is the answer. Right? Right, next one. Basically, potentiometer is a device for. Basically, potentiometer is a device for. Now tell me, basically the potentiometer is for which purpose? So in the potentiometer, what we do? Unknown voltage is compared with respect to the known voltage. From that only we are getting. That's why it is for which one? Comparing two voltages. But people are getting doubt, sir, measuring the voltage, yes, measuring the voltage after comparison. That's why he has given that basically, therefore you have to go for comparing two voltages. After comparing unknown with known, whether it is balanced or not, then unknown equal to known, etc. So therefore we are comparing. After that we are measuring. Therefore basically means comparing the two voltages is the answer. Right? Next one. In order to achieve high accuracy, the slide wire of a potentiometer should be, right? See, in my explanation also, I have taken the slide wire length is 200 centimeters, like 2 meters. Even the questions also we have taken simply 1 meter, 75 centimeter, 1.5 meter, etc. Why, sir? To get high accuracy. That's why the potentiometer wire must be as long as possible. As long as possible to have high accuracy. As long as possible to have high accuracy. Now, next one. Volt box basically used for nothing but volt ratio box we say. volt ratio box is generally used to extend the range of potentiometer. So therefore, extending the voltage range of potentiometer. Volt ratio box is especially for extending the voltage range of the potentiometer. Right. Next one. Here from electronic part, CRO can display. CRO can display. So in the CRO, DC signals are possible as well as AC signals also possible. Therefore, both DC as well as AC. Both DC as well as AC is the answer. And when measuring, very important question, when measuring phase angle between two waves using CRO, the time base generator is connected to. The time base generator is connected to. While measuring which one? Phase angle between the two waveforms. Now tell me, where we connect the time base generator in this process? Everyone answer. Where we connect? Time base generator. Guys, first of all you need to understand the phase angle between two waves means indirectly he is asking with respect to which mode? Non-sweep mode. Non-sweep mode. So if the non-sweep mode is there, do we have sweep generator, sweep signal over there? No way. That's why neither with X nor with Y plates. Suppose if the question is given like in sweep mode of operation, then definitely to the X plates the time base generator will be given. But this is asked in terms of phase angle between two waves. Phase shift is from the Lissajous figures only. Lissajous figure means non-sweep mode of operation. From the in the non-sweep mode of operation, we don't have time base generator because sawtooth we don't give. Directly two sine waves will be given to the two plates without conversion of sine wave into corresponding sawtooth. That's why neither X nor Y plates. Clear? Yes, Gaurav Dubey. Very good. Okay, nice. Next one. Q meter works on the principle of. Q meter works on which principle? Q meter means a quality factor meter. Q meter means quality factor meter. It is working based on series resonance principle. In the Q meter, RLC will be there. So RLC series, therefore it is working based on the series resonance principle. Right? Next one. For measuring current at high frequency, we should. For measuring current at high frequency, he is asking about high frequency. Now tell me, moving iron instrument, normal our laboratory frequency 50 Hz we can say. Electrostatic, same. PMMC also a laboratory instrument only. The two, PMMC is not for AC, only for DC, leave it. He is asking it high frequency means definitely thermocouple type, because these are normally 50 Hz, nothing but laboratory. It is anyway not for AC, so remaining option will be thermocouple. That's why thermocouple instruments are basically for what is high frequency measurement is also possible. Right? Yes, series resonance, correct. Gaurav Dubey, thank you so much. Right, next one. In a thermocouple temperature transducer, the output voltage is usually measured by. Sir, in the thermocouple, the output voltage will be measured by nothing but in the thermocouple, two junctions will be there. The moment we give the heat to or temperature to one junction, junction temperature difference will occur. Therefore, thermoelectric EMF will be developed and therefore we can get the electrical output. But that electrical output will be very small value, millivolts in the range. That's why high resistance millivoltmeter. Voltmeter should have anyway high resistance, but the two thermocouple output will be very small. Therefore, high resistance millivoltmeter is the answer. High resistance millivoltmeter. Next. LVDT is a LVDT is, now tell me what is this LVDT? LVDT means, I am writing the full form. In few examinations they may be asking like full form of, right, expansion of LVDT also they will be asking. So therefore linear variable differential, linear variable differential transformer. This is LVDT. Now this LVDT is for which purpose? For linear displacement, for linear displacement purpose. For linear displacement purpose. Now check it. So LVDT is a pressure transducer, no. Velocity transducer, no. Acceleration transducer, no. So simply displacement transducer. Why? It is for the purpose of measurement of linear displacement. So automatically yes, linear displacement transducer, right? Okay, right, option B. Next one. Shaft encoder is used to measure. Shaft encoder is used to measure. What is the corresponding shaft encoder used to measure? This is directly angular position. Shaft itself is simply, it is a rotating structure. In that you can remember that it is for angular position, not linear position, not linear velocity, not linear acceleration. Why sir? Shaft means angular notation. Therefore only one option is there, angular. Therefore we can go for angular position. Right? Next one. The speed of a DC machine can be measured by, the speed of a DC machine can be measured by in your laboratory, in our machines laboratory, electrical people, in our machines laboratory, while doing the experiment, we use one device and we keep in that corresponding shaft pointer. So therefore we are going to measure the speed. What is the device name? Tachometer. So therefore tachometer is for speed measurement. Tachometer is for speed measurement. And ammeter is for current, voltmeter is for voltage, anemometer is for flow, like that we can say. So simply which one? Tachometer is the speed measuring device, right? Yes, very good. Tachometer given by you people. Electricity produced from dash is called piezoelectricity. Electricity produced from dash is called piezoelectricity. Tell me. Electricity should be produced from dash is called piezoelectricity. Simple. I am taking one piezoelectric crystal. I am taking piezoelectric crystal. Like this I am taking. Now this is piezoelectric crystal. Piezoelectric crystal. Now for this piezoelectric material structure we give which one? Force. We give force. Force per area, pressure we can say. That to which force? Dynamic force we give. Dynamic force. The moment we give the dynamic force, right, automatically due to the molecular displacement etc. deformations, we are getting positive charge on one electrode, negative charge on other electrode. Why sir? One end will be of course taken as a fixed one. This is simply fixed one. So therefore the moment you apply the piezoelectric material nature itself is, it is generating the corresponding charges. Plus is on one body, minus is on other body. So automatically from this what we can take now? We can take here electrical output V0 we can take. This is called as piezoelectrical principle. Piezoelectricity we can say. Piezoelectricity. Now tell me, in this by applying the force, we are getting the electrical output directly, means is it active transducer or passive transducer? Means active only. Yes, piezoelectric transducer is active transducer. Why sir? It is generating the electricity, it is generating the electrical parameters on its own, nothing but it does not require any supply for its operation. Directly it will be generated. That's why self-generating. Active transducer, or we can say self-generating transducer. Active transducer or self-generating transducer. Now with this entire idea, electricity produced from dash is called piezoelectricity. Sir, heat? No. Light? No. Velocity also no. So therefore which is the correct one? force should be there, but force by area, simply we can say pressure. So therefore answer will be the pressure. Right. So from the pressure application, nothing but from the force application, we can say yes, correspondingly non-electrical input is converted into electrical output. So therefore it is generating on its own active transducer and self-generating. So automatically option will be the pressure. Clear, guys? Right. So these are the questions related to the entire session. So these are the PYQs from the measurements part, that is electrical measurements, electronic measurements and transducers. So with this I am concluding the session. All the best. Thank you.